All right, let's do this. Chapter 13, Lesson 8, double angle and half angle formulas. Okay. Sorry, try to get this focused a little better here. There we go. Okay, the objective says to use the double angle and half angle formulas for sine and cosine. So we're going to be learning what double angle and half angle formulas are. Let's read it. It says you can obtain formulas for the sine and cosine of twice an angle by substituting alpha and beta in the formulas for sine of alpha plus beta and cosine of alpha plus beta. So let's look at how they derive this thing. So what we're going to do is, if you have the sine of twice something, eventually you'll be able to figure out what it equals by knowing the sine and cosine of whatever half of it was. Does that make sense? So let me see. So like this, let me show you. So if we have the sine of, I'm just making stuff up, 16, but you don't know what the sine of 16 is. Well, if you do 2 times the sine of 8 times the cosine of 8, because you know what those are, these will be equal. So we're going to figure out how and why this works and then what to do with it. Okay, so the sine of 2a is really the same thing as the sine of a plus a. That's just 2a. And we know that the sine of something added to something else from the last lesson is equal to the sine of that times the cosine of that plus the cosine of it times the sine of that. Since they're the same, these look the same. And therefore, we have the sine a cosine a times 2. So we said that the sine of 2a is equal to 2 times the sine of a times the cosine of a. The same thing happens here with the cosine. When you have the cosine of 2a, it's equal to the cosine of a plus a. And we learned from the last lesson that the cosine of something plus something is equal to the cosine of both of them minus the sines of time of both of them. Therefore, it's the cosine squared a minus the sine squared a. So we've got these 2 little formulas to put in our gray box. They call these formulas the double angle formulas for sine and cosine. Now, if we use the Pythagorean identity, sine alpha squared plus cosine alpha squared equals 1, then we can get these guys. If the cosine of 2a is this, which we got right here, and this is equal to 1 minus the sine squared of a, then we have 1 minus sine squared a minus sine squared a, and we get 1 minus 2 times the sine squared of a. So what we did is we took this and we combined it with the Pythagorean identity and we got this. Did the same thing here to get this. Okay, so look at the gray box and you've got all 4 of those things worked out here. The sine of 2a is 2 times the sine of a times the cosine of a. The cosine of 2a is this or this or this, and you just got to have that locked down. So let's look at a first example. It says if the sine of a is 3/5. Okay, so we know that whatever a is, the sine of it is 3/5. So we don't know what the angle is, but we do know that it's equal to 3/5. And we know that the alpha is in the second quadrant. The second quadrant means the angle is somewhere in between here. Okay? Can we find the sine of 2 alpha and the cosine of 2 alpha? Well, the answer is yes. We can, using our new formulas. We're going to be using this 2a business. Okay, so let's look what happens. When we draw this angle out, we know that the sine of this angle is 3/5. Now sine, let's just pick it out here and draw our little angle. The sine of this angle, right, is opposite over hypotenuse. So we know that that's going to be 3 and that's going to be 5. Now, use your Pythagorean theorem to see that this will have to be -4 because this is a right triangle. And it's negative since they told us it was in this quadrant. So this has to be negative. So now, can we figure out the cosine of A? So the sine of this thing, they told us, was 3/5. What's the cosine? -4/5. So now if we have the sine and the cosine, can we figure out the sine of 2A and the cosine of 2A? Yes, because look right here. We're going to use this gray box formula. The sine of 2A is equal to 2 times the sine of A times the cosine of A. So what's the sine of 2A? Well, the sine of A is 3/5. So 2 times 3/5. And the cosine of A is -4/5. So all we got to do is multiply across. We have -24/25. So the sine of 2A is -24/25. And then we do the cosine of 2A the same way. So looking right here, we've got the cosine of 2A is equal to the cosine squared of A minus the sine squared of A. Well, we know what the cosine of A is. It's -4/5, so we square it. And then we know what the sine is, and it's 3/5, and we square that. And so that's got to be the cosine of 2A, which would be 16/25 minus 9/25. So the cosine of 2A is 7/5, or 25, excuse me. Okay, makes sense? All right, next page. Formulas for the sine and cosine of half an angle can be derived by replacing A by theta over 2 in 2 of the formulas for the cosine of 2A. So what we're going to do is, if you know that you have the cosine and the sine of A, then you can figure out either one with 2A. Well, now, if you know the cosine of A, then you can do half of it. So that's what we're figuring out here, is what to do if you know this to get half. If we knew this, we can get to 2. If we know this, we can get to half. So let's look at what they did here. It says cosine of 2A is 1 minus 2 sine squared A. That was one of the things we came up with just now. If you replace the A with theta over 2 and you simplify everything, then you're left with this. The sine squared theta over 2 is equal to 1 minus cosine theta over 2. And then you do the same thing here to get this. So we're going to take the square root of both sides, and we'll get this. It's called the half angle formula. So the sine of half of an angle is plus or minus the square root of 1 minus cosine theta over 2. And then the cosine of half of an angle is equal to plus or minus the square root of 1 plus the cosine over 2. Notice that they both have the plus or minus. You have to decide which one to use by seeing which quadrant the angle is in. Let's look at an example. Find the exact value of sine 7 pi over 8. And another example is find the exact value of the cosine of 165. Let's read through how they do it. 7 pi over 8 is a second quadrant angle. Now 7 pi over 8. Okay, let's think. Where is that? Well, we know that 8 pi over 8 is pi. That's 180. And so 7 pi over 8 is, let me think. It's going to be like that. Because this is pi over 2. And so that would be, all right, let's just do it. I can't think this morning. So 90 is pi over 2. So that means that pi over 8 would be divided by 4, 22.5 degrees. And so we want 7 of those. Right? So 7 of those is 140 plus 14 plus 3.5. So that's 157.5 degrees right there, which makes this guy 22.5 degrees. Okay, so 7 pi over 8. So 7 pi over 8 second quadrant angle, so this sine is positive. And 165 is in the second quadrant, so the cosine's negative. So look how we do this. 7 pi over 8 is the same thing as half of 7 pi over 4. So the sine of 7 pi over 8 is the sine of 1/2 of that. So if we know the cosine of this, then we can figure out the sine of this without ever actually knowing it. This is kind of cool. So 1 minus the cosine of 7 pi over 4 divided by 2. The cosine of 7 pi over 4 is square root of 2 over 2. And we got to go back to that chart on whatever page it was. So square root of 2 over 2. 1 minus the square root of 2 over 2, all divided by 2. Convert that to 2 minus square root of 2 all over 4. And we do 1/2 times the square root of 2 minus square root of 2. That's the sine of 7 pi over 8. The same thing happens here in degrees. 165 degrees is the same as 1/2 of 330. So the cosine of that is the cosine of half of it. We can use the half formula. 1 plus the cosine of that, which we can figure out from that same chart, over 2. Square root of 3 over 2, simplify, there's our answer. Okay, 2 more examples here. Okay, now look what they're doing here. If the angle that we're interested in is bigger than 180 and less than 360, let's make sure we track what that's looking like. So bigger than 180, so it's somewhere in here. It's bigger than 180 and less than 360. So the sines will be negative. The cosine might be negative. The cosine might be positive. The cosine is negative 5/13. So that means we're over here. So that would be negative 5, and that's 13. Find the exact value of each of the following. What's the sine of half of the angle and the cosine of half of the angle? Well, if we know that 180 degrees, or if we know that the angle is between there, then half of it is in the second quadrant. Divided by 2, divided by 2, divided by 2. We're in the second quadrant. And sine of a over 2 is positive, and the cosine of a over 2 is negative. So look what they did. They went ahead and divided it to know that, okay, 180 would be 90, and 360 would be 180. So somewhere it's living over here. So the sine of this number has got to be equal to the positive, because the sine is up here, positive, and the cosine is negative. So the sine is positive, and the cosine is negative. And this is just a copying of the formula from the other page. Copying of the formula from the other page. Then, since we know the cosine, we plug the number in. We know the cosine, we plug the number in. You solve it, and those are the answers. Not too bad. Okay, now example 4 says prove the following identity. You have the cosine of theta times the cosecant of theta minus the sine of theta times the secant of theta should equal 2 times the cotangent of 2 theta. Okay, so what we're going to do is we're going to manipulate the left side in order to generate 2 cotangent 2 theta on this side. So what did they do? Well, the cosine and the cosecant, they changed the cosecant to 1 over sine, and they got this. They changed the secant to 1 over cosine, and they got this. Now notice, when you get a common denominator, sine theta, cosine theta, you end up with cosine squared minus sine squared on the top. And you end up with sine theta, cosine theta on the bottom. Then they're multiplied by 2 over 2, because the top will now become cosine of 2 theta and the sine of 2 theta, all multiplied by 2. Because this is equal to this, and this is equal to this. So Cosine over sine is the cotangent. So we have 2 times the cotangent of 2 theta. We got it. Okay, let me know if you have any questions or if you get stuck on a problem, just send me a little message or something.